Hey everyone, and welcome to another video. A few weeks ago, I posted a video in which I was talking about doing simultaneous behavior classification per frame and doing pose estimation on the same frame in a single model pass. And I got some great feedback from some of you who reached out. Thank you so much. So in this video, what I will do is I will demonstrate a project that I've put on GitHub, and how this works is that it builds off of the Ultralytics library and allows you to train custom models for yourself that can do both behavior classification and pose estimation simultaneously. So I have source videos here from Behavior Depot, some from my previous publications, and some that I recently collected, like here, the mouse in the home cage environment. Now, one caveat about this is that the behaviors that it has the ability to distinguish, or that you can train it to distinguish, have to be visually discernible. Okay, with that out of the way, I want to go over the pipeline. And by the way, keep this in mind that the repo itself is still under development. I will be adding some features some features into this repo later, and also updating the documentation for it. But at this point, it's good enough for, in my opinion, for people to try it out, give me some feedback, and see what you guys think. If you are ready, please go ahead and download the zip file. And when you're inside of that folder, you will see two folders. The first folder, behavior annotation underscore model training. This is the first pipeline. It allows you to go from setup to annotation to model training to inference, and then if you're ready for it, webcam interface and running real-time application and detecting behaviors and poses in real time. Okay, this one needs significant work, so this one is the least I'm comfortable sharing, but I have it there. Some of you may be able to help me with it, and feel free to, do so. Okay, so starting with the setup and the annotation. So setup and annotation is fairly easy. If you are familiar with the way you need to have your labels and images set up for training a YOLO model, it's exactly the same way. So your images folder need to have two separate folders, one for training and one for validation, and you're going to need to have your training images inside of that folder. Okay, so validation folder has these images that are for validation. And then same thing for the labels. Labels folder will have labels for training and labels. These are the annotations for validation. So once you have that set up, give let's do this one. Let's give the annotation images path here, and I'll create the labels over here so they stay separate from my other ones. Once you have those, you can start and launch the annotator. You can define your key points before you start the annotator. Define your behaviors that you want to track, and you can always add more, something like this. You can always add more or remove them using the remove select button. So launching the annotation tool will give you something like this. You can zoom in, zoom out using command or alt on Windows. I think you can pan your frame up and down, and then using the keyboard keys, numbered keys, you can pick the behavior that you see. Here, for example, I see the mouse is walking. I'll pick that one and then start annotating. Something like this. Okay, so there's mouse number 1 done. For the second one, this guy is doing some different behavior, but I don't have that behavior, so I'm just gonna. So if you mess up like what I did here, you can always press U to undo your key points and then replace them. So something like that. If you're done, just press Q. It will ask you to save. And then once you save it, your annotations will show up over here. The first number in this list of numbers is the class, the behavior ID class. Okay, so and then at the end there's a visibility flag also. If your key points are invisible or they're hidden behind some other object, but you want your model to learn that they are there, you just assign the visibility flag. By the way, you can also turn that flag on and off. Like here, for example. So if I want to turn this visibility flag off, I'll press the middle mouse button and that will turn red. So green is visible, red is invisible. If you know you have multiple key points that are going to be invisible, you can press the V button, and any key point that you place after pressing that V button will have this visibility turned off. Okay, so with that out of the way, I already have my models trained. This was here to demonstrate. The last panel in this first tab is for you to generate a YAML file that can be used for training your YOLO model to do both simultaneous key point tracking and the behavior identification. And this is fairly self-explanatory. Once you have all of these things filled out, you're going to press generate. It will generate it for you. It's going to look something like this. It will have some comments here for you. It will give you the key points that you have used, the names for them, and then the names of the behaviors and the classes of behaviors that are going to be in your training. Okay, so next tab over is the model training. Once you have your model configuration like this set up, you're going to give the path for this to your you will input that path over here and then give it a root directory path where you want to save the model. I recommend using a pre-trained 11 nano model pose.pt. So type in this. It will automatically download that. If it doesn't exist, it will download it for you before it starts training. And then experiment name, you can name it whatever you like. Home cage experiment 1, 2, whatever you like there. If you want to use your GPU for training, change this flag to 0 to allow GPU to be accessed. And in order to use GPU, you're going to need PyTorch. And you can download PyTorch. Just type in Google PyTorch installation, download it for your specific CUDA version. And then pressing the training button will start the training. Inference, you need, once you have your trained model, you can put the path for your trained model over here, video source over here. So let me demo this for you. All right, so I'm going to go ahead and demonstrate what a good trained model can do. Here I have moved my weights from my training folder into this working directory so that I have access to everything in one single directory. I'm going to be using a tracker here like this. This one I need to change to GPU. This one maximum animals. There are only 2 animals in this folder, and I will create a new folder to save tracks, and I want everything to be saved in this one, and I'll call this test. I want save annotation data augmentation. I don't want to apply that at runtime. I do want to save the results, and yeah, basically just that. And the line width I want to be 3, and I will leave everything else as is and just run. Okay, so here's the video, and if I pause it here, you can see the majority of the inference times here on the right side on my command line interface are about 10 and 14 milliseconds per frame. So nose poke happened, and nose poke got picked up around 15 millisecond per frame inference time for that. You can obviously decrease these inference times by quantizing your models, but just pay close attention to the accuracy of the model if you do try to quantize the YOLO model outputs. Okay, so the mouse number 2 merged in this one, mouse number 1 from the left side and came out on the right side, and the track IDs are maintained. Now these track IDs are basically, you'll have to fiddle around with this proximity threshold and the appearance threshold parameters for the re-identification algorithm, but other than that, it works really well. So I'm going to go ahead and let this one play out. I will pause the OBS, and then we will take a look at the other module that I have in the GitHub repo that you can use for some kind of about analysis and some unsupervised clustering of the behaviors. Some neat things over there, but they're not really fully developed, so take it with a grain of salt. All right, so I will pause the OBS and then come back after this video has finished. All right, so the video finished, and over here it gives me the speed at the end here. And as you can see, it's 0.9 millisecond pre-processing time, 13.6 millisecond inference time on average, and 1.6 millisecond post-processing time per image. 13.6 millisecond inference time for doing all three of the things, which is tracking and then doing pose estimations and also doing behavior classification all in a single pass of the model is pretty good, I would say. Now I'm going to shut this down. By the way, feel free to give me feedback on the webcam interface integration. This is going to take quite a while to fully develop. So I'm going to close this out. And then let's go over to the IntegraPose EDA. I will run this Python script. So this one also has a graphic user interface. And for this one, you will need a behavior data file, the YAML configuration file, to import the configurations. And you can obviously import the names that you are using for your key points like this, and then the directory where you have saved. I saved it here. These are the labels. Okay, I'm going to normalize all of my detections to the bounding boxes. You can also choose key point, a specific body part to normalize your detections to, but I find the bounding box to be fairly standard. Then over here, you can design your skeleton however you want to set up your skeleton. Then select all those features that you want and then calculate, basic, this is basic feature engineering. On the next tab, you can do some unsupervised clustering. Let's say you want to cluster 42 features. So pick 42 for this one, and you want to cluster them into 3 groups. You can do that. Okay, you can see the clusters overlap. They're not very good, but down here in the output summary, it tells me that my dominant behaviors per cluster are like this. So walking, walking, and then walking. So it's not doing a very good job of clustering my behaviors. Well, anyways, that's not a problem. So if you want to look at the average poses, you can pick any one of these from here and then plot average pose. This will show you what the average pose and different body parts, where they fall on average after being normalized to the bounding box of the animal. nose poke. Here's the rear, when the mouse is doing a rear behavior. And if, let's say, I want to do wall rearing, this is what the mouse's overall posture looks like when it's doing wall rear behavior. So starting with the nose here, dark blue, and then purple is the right ear, green is the left ear, pink is thorax, mid back, and then the tail base. On the next tab, you can import your video, and also then do nose poke. So when you filter the behavior, you can play this out, and when that behavior happens, it will show you exactly where that behavior falls in the PCA spatial domain. Here, so I paused it here. This is where the star pops up. Okay, and if you want all behaviors, you can obviously have the all behaviors. In my case, this looks like a mess. It's very hard to see what is going on. Okay, but anyways, you get the idea. You're gonna have to kind of fiddle around with this and see, you know, where your behaviors are falling. And you can obviously do stuff like, you know, pairwise plotting. So feel free to use this as you like. This is for exploratory data analysis. Most of the time you will not be doing so much exploratory analysis, and you will be using this tab number 5, which is to do experimental bout analysis. Basically give your FPS over here. In my case, I had 60 FPS, or rather 59.99 FPS. After you do some kind of a basic statistics like this, then you can go on to assign the minimum bout duration for your experiments. So minimum bout duration just helps eliminate spurious detections of behaviors that might happen. Let's say a mouse jerks a little bit, but that jerk to the model looks like a grooming behavior, so it might label a couple of frames in your sequence as a grooming behavior, but it's not really a grooming behavior. Therefore, you can filter that type of an instance out of your detections by setting up your, you know, filter right here. So you can pick whatever makes sense for your experiments. Maximum gap is similarly used, but for the opposite reasons. You might have a gap in behavior, but that gap is a spurious detection event. Therefore, you want to merge that gap with the previous behavior that was happening, and you want to have a maximum gap region defined over here. So pick whatever makes sense for you, and then once you press the advanced bout analysis, it will ask you where you want to save it. I'll just go ahead and save it to the main directory, and then in that case we will be able to see how many nose poke events happened, how many rearing events, walking, you know, so on and so forth. And then it gives you all that information as an Excel file. It gives you all that information as an Excel file and as a CSV. Excel files contain the summaries. So wall rearing, track ID number 1, so animal number 1, animal number 2, walking for animal number 2 is down here. It completely got rid of the, oh wait, wall rearing, animal number 2. This is interesting. Animal number 2 didn't do any wall rearing or anything like that. And we can confirm that by looking at the video. Number of bouts, rearing 1, walking 7 bouts for animal number 1, wall rearing 6 times, nose poking 4 times. And these are the average frames, durations in frames that happened. I know this video was about a 1-minute video, and I can go back here to show you that too. So from beginning to the end is about 1-minute video. And this is telling me that mouse number 2 for the entire duration did nothing but walking. That, I mean, it depends on how you assign your maximum gap duration and minimum bout duration here. Okay, but for my video, this is for demonstration. I don't really care right now for being too accurate. Any visualizations that you generate over here, you can save those to wherever you like as a PNG file. And at the end, you can export all of your data. Let me save it all here. And so all of these are processed raw data frames like this. So object ID, behavior ID, and then it also gives you these behavior names next to it too. Okay, with this out of the way, I hope that you found this to be interesting, useful. Please give me feedback on this, and hope this can be of some help to some of you out there. Thank you so much.